Let's solve the part 3 problems. So when we have y double prime plus 5y prime plus 6y equals to 0, you are free whether you can pick your independent variable to be time or you can pick it to be x. So whichever you pick will be okay. So the first one we have y double prime plus 5y prime, and then plus 6y equals to 0. So the first step is to form the characteristic equation, solve that characteristic equation, and then see the nature of the roots. So we'll assume let y equals to e raised power r t be a solution. This is not fashion. You have to show where you are getting your characteristic equation. So you need first derivative and also second derivative. So that means y prime is r e raised power rt, and y double prime is r squared e raised power rt. So the equation becomes r squared e raised power rt plus 5 r e raised power rt plus 6, but y is e raised power rt equals to 0. I'm allowed to equate it to 0 because I've already said that this is a solution. So we'll have r squared plus 5r plus 6 e raised power rt equals to 0. And since an exponential function can never be 0, that means r squared plus 5r plus 6 is what gives you 0. So this is what we call the characteristic equation. Now we can use any of the methods we like to solve quadratic. It can either be factorization, it can be completing the square, it can be quadratic formula. So r would be minus b plus or minus square root of b squared minus 4 times a times c divided by 2 times a. So what is the value of the square root? Value of the square root? 1. So because between 5 minus 24 square root of 1 is 1. So which means then R1 is minus 5 plus 1 over 2, and R2 is given by minus 5 minus 1 over 2. So R1 will be negative 2, and R2 negative 3. So these are real and distinct. So which means that y1 function is e raised power r1, which is minus 2 times t, and y2 is e raised power minus 3t. Yes? Criteria I'm using to get? Okay. There's nothing special. There's nothing special. Unless they give the order in the question, there's nothing special. You can as well call -3 or R1. Yeah, so there's nothing special with the ordering. You can call anything R1 and the other R2. But unless maybe the equation has given you a structure in which you have to put your characteristic roots, then you can do that. But unless otherwise, you can give the order the way you like. Okay. So general solution is given by y of t equals to c1y1 plus c2y2. So which will be y of t equals to c1 e raised power minus 2t plus c2 e raised power minus 3t. Someone who calls R2 their -3 their R1 will have c1 e raised power minus 3t and plus c2 e raised power minus 2t. There's nothing special with the ordering, provided you take care of all of them. Or if you decide you want to use your independent variable to be x, you do the same thing we have done, but where there's t, you replace by x. Still okay. But don't mix x and t in the same problem. If you decide you are going to use t, let it be t throughout. If you decide you are going to use x, let it be x throughout. So don't mix x and t in the same problem. Can you be trusted with the second problem? Can you be trusted with this? Number 2, y double prime minus 7y prime plus 12y equals to 0. Get the roots of the characteristic equation. Please remember, when you're solving this question, if you are given, what I'm writing here is not fashion. You have to see this. If I don't see this in your working, then you are doing nothing. You have to explain where you are obtaining your characteristic equation. So all this up to this point here, where we are solving the characteristic equation, you have to show how it's obtained. Though I know it is very easy to know it from the question even without writing down, but you have to show those steps. So in B, what is your R1 and what is your R2? R1 will be three and four, correct? 3 and 4. So 3 and then this is 4. So which means your y1 is e raised power 3t, and then y2 is e power 4t. So the general solution for that equation would be y of t equals to c1y1 plus c2y2, which will be c1 e raised power 3t plus c2 e raised power 4t. Then can you try C? So C, for those who have not written, is y double prime plus 3y prime minus 10y equals to 0. Two and negative 5. Yeah, 2 negative 5. So which means y1 will be e power 2t, y2 will be e power minus 5t. So the final solution y of t is the linear combination of these two solutions, which will give us y of t to be c1 e power 2t plus c2 e power negative 5t. So if you are given extra information about the y function, we can get the values of c1 and c2. Now, next example D, we have d squared y dx squared plus 4 dy dx plus 4y equals to 0. So write this next example. So in this case, you don't have the freedom of picking what you like, because the question is clearly requiring the independent variable to be x. So therefore, you'll start by saying, let y equals to e raised power rx be a solution. It's very clear that the function y depends on x. So you don't put t, because it's already conspicuous in the problem itself. So that means dy dx will be r e power rx, and the second derivative of y with respect to x will be correct, r squared e raised power rx. So we use those values to replace into the equation. So using these values in the equation, we get, so r squared e raised power rx plus 4 r e raised power rx plus 4 e raised power rx equals to 0. What will be the common term on the left? AR, e raised power rx, okay? So e raised power rx equals to 0. And the same analysis that e raised power rx can never be 0. So which means r squared plus 4r plus 4 equals to 0 is our characteristic equation. So solve for R. Tell me R1 and tell me R2. So it's repeated, -2, -2. So which means the Y1 will be given by okay, so when you are writing the functions themselves, you C1 will be placed in the final answer linear combination of the two. Correct. And Y2. Remember, the solutions should be linearly independent. Check what you are writing on the general analysis of the solution. When you get two repeated real roots, x e power -2x. Okay? Yeah. So therefore, so these are the two linearly independent solutions. So y of x will be given by c1 y1 plus c2 y2, which will be y of x equals to c1 e raised power -2x plus c2 x e raised power -2x. If you like, you can write it as c1 plus c2x and then e raised power -2x. E, we have d squared y dx squared plus 6 dy dx plus 9y equals to 0. So solve and tell me what is R1 and R2. Is it also repeated? -3, -3. So which means y1 is and then y2. Correct. So then the final solution y of x is the linear combination of the two solutions, which will be c1 e power -3x plus c2 x e raised power -3x, which you may write c1 plus c2 x e raised power -3x. That was E or F? That was example E, and then F, we have y double prime plus 4y prime plus 20, y equals to 0. subject to y at 0 is given by 3 and y prime at 0 is given by -1. So this is an initial value problem. Can you be trusted with the process of finding the characteristic equation? What will be the equation? You will show the steps, yes, but show the steps on how you are getting that, but you can read it from the equation itself. Will be given by r squared plus 4r plus 20 equals to 0, okay? Yeah. So when you do all the process, you should find that this is the characteristic equation. And what is R1? And what is R2? So -2 plus 4i, and this will be -2 minus 4. For I. So complex conjugate roots. Now, remember, in this case, alpha is -2 and beta is 4. And when you have complex conjugate roots, we say that y of t is given by e raised power alpha t into C1 cosine of beta t plus C2 sine of beta t. So which will be y of t is e raised power -2t into C1 cos of 4t plus C2 sine of 4t. That's what we call the general solution. Yeah. But now, when you are given extra information about the problem, you can go ahead and find the values of the unknown constants C1 and C2. So what is the derivative of this function? We use which rule? Product rule. So u prime. But what will be the, if you are to fish out the y1 and y2? What is y1 in this question? Y1 will be a -2t sine, a cosine of 40, and y2 will be correct. So the derivative use product rule. So when you differentiate this one, we get -2 e raised power -2t. I multiply by the same function. Plus, when I differentiate inside, I get -4 C1 cos sine 40 plus 4 C2 . Do you agree with that answer? Yeah, so this sine and this side, this part is cos. So I'm doing that because in our initial conditions, there is a value of derivative of the function. So that's why I'm getting the derivative. You see, we were told that y prime at 0 is -1 and y at 0 is 3. So y at 0 means where there's t in the equation for y, you put 0. And this must always give us what is the value at 0 from the question itself. Y at 0 is 3. So it's already given here. We are told that y at 0 is 3 and y prime at 0 is -1. So this must always give us 3. Now e power 0 will give us 1. Cosine of 0, sine of 0. So which means C1 is what? 3. Correct. And then y prime at 0, you replace 0 at every point where there's t. This must always give us -1 from the question. So what do we get in the first bracket? We get C1, second bracket, or C2. So this is like equation 1, this is equation 2. So solve for C2. So those are two simultaneous equations. Solve for C2. Five over 4, correct. So C2 is 5 over 4. So therefore you say the specific solution is you rewrite the same general solution, but the only difference is that you replace C1 by what you have gotten as 3 and C2 as 5 over 4. So I'll have y of t is given by e raised power negative 2t into 3 cosine of 4t plus 5 over 4 sine of 4t. So that's how we solve that problem. So let's separate jokers from serious people on this. But I know you will get it anyway. It's not a very hard problem. So solve d cubed y dx cubed minus d squared y solve for me that equation. How many roots do you expect in that case? 3, because it's up to third order. So tell me R1, tell me R2, and tell me R3. R1 is 0, correct? R2? R2? -2? And R3? Is it negative or positive? Is it +3 or -3? Confirm. I have +3. Because you see what you're doing from this equation, it is not hard to see that this is the characteristic equation, okay? That's a characteristic equation. Then you can factor out R. So 1R is 0. So this was giving us 0. So when you solve this quadratic, is it -2, -3, or -2, 3? Just confirm. So someone has -3 too. Okay, we can now. Let's just do it together so that now we can know which is the correct answer. So we'll have, in fact, product is -6, sum is -1. What are the numbers? And 2. So which means we'll have R squared minus 3R plus 2R minus 6 equals to 0. So R into R minus 3, 2 into R minus 3. You don't need St. Peter's to say the answer. So positive 3 or negative 2, okay? Yeah. So negative 2 and positive 3. So how would what would be our y1? Yeah, not okay. So we'll bring in the C once we have all the combination. Before we do that, it's just one because we'll have e raised power 0 times t, okay, or times x. So 0x, so the variable used there is x, and then what will be the value of y2? Right. So this is 0 times x, which is just 1. Y2 is e raised power negative 2x, and y3 e power 3x. So the solution will be y of x is c1 y1 plus c2 y2 plus c3 y3. So which means we'll have c1 plus c2 e raised power minus 2x plus c3 e raised power 3x as our final answer. Can you dare this? If you get this one correct, then we stop. If you get the solution to this equation correctly, then we can stop at that point. Yes. A constant somewhere like. Yes, that's a good question. And that's what I'm likely to set. So you must have done what we call polynomial factorization. And this being a cubic, it may or it may not be easy to factorize, but you can always use okay. You can always use what you okay, that's the problem. You can always use what we call long division if you get a linear factor of the polynomial on the left-hand side. And for you to get that linear factor of the cubic equation on the left-hand side, you list all the factors. So if you miss such a problem, to do the factorization to solve R, try to check whether if you write all the factors of this constant number. So for the example, this is 3. So the factors of 3, we have 1 and 3 itself, but even -1 or +1. So +1 or -1, +3 or -3 are factors of the constant term in this cubic equation. So you do trial and error. You try to replace -1 into the equation and see whether the two sides will balance. If it works well and okay, it will be meaning that R equals to 1 is a root of that equation, which means R minus 1 is a factor. Or if you try to replace -1 for r and the left-hand side gives you 0, then it will be showing that r equals to -1 is a root of that equation, which means r plus 1 is a factor of this cubic part. So then now, assuming that is the case, r plus 1 is a factor, you can use long division to see the quotient in that division, which will be a quadratic function or a quadratic expression, which you can easily solve. I don't know if I've helped on the equation. That in such scenarios, you concentrate on the constant term without the variable, list all the factors of that constant number, make them plus or minus, and try to fix in those numbers to see which one satisfies the equation. If you get the one that satisfies the equation, then you'll be saying that r equals to that number is a solution. Then bring the number to the left to give you a linear factor of the quadratic part. Those who are doing IO9, remember how you are getting the eigenvalues and eigenvectors. Yeah, so that's the same process. So sometimes when you have a 3x3 matrix, you'll end up with a cubic characteristic equation. So to solve that cubic, if you can't see the factors directly, then you can use the constant number to get the factors of that cubic. It will be a nice exercise to do. I'll try to get some questions which may not necessarily be on ODs, but just cubic or quartic or quintic equations that need some factorization. So you can practice on that. There's an excuse. Yes. Okay. Do you have the question closer to you? Can you give me one closer to you that we can actually deal with it and then see how we are supposed to deal with it? Yes. Why? Cubic prime? Why double prime? And then? And then? Plus 6y equals to 0. Okay. So I hope all the process that leads to the characteristic equation can be done. Can I trust that with you? Okay, so please mute your mic. I believe that you can do all the processes that leads to the characteristic equation for that given equation. Is that true? Yeah. So which means the characteristic equation, after doing all those steps, will be r cubed minus 4r squared plus r plus 6 equals to 0. I hope everyone is able to do that, okay? But please ensure that you don't do this one directly if you are given this problem to solve. Show all the steps that leads to that equation. Now, we see that if we try to factor out, say, r squared here, and then you say r minus 4, and then plus 1 into r plus 6 equals to 0, this is fun. because factorization dictates that this bracket must be the same as this other bracket. So we can't do that. So what we will do in this case, we'll use the constant term that has no r to test the roots of this given equation. So the number we have is 6. What are the factors of 6? 6, 3, 2, 1. And then you can make them plus or minus. So it can either be -6 or it can be +6, -3 + 3, -2 + 2, or -1 + 1. Then you do trial one by one. When r, say, is 1, does that equation on the left-hand side gives you 0? No. So therefore, this doesn't work. If we put r equals to -1, is it true that -1 cubed minus 4 -1 plus -1 plus 6, is that 0? So these are square. Does that give, so r equals to -1, does it make 0? So then we are lucky. Positive cannot work because you see 1 cubed is 1, this will get -4, this will get +1, this +6, it can't be 0. 8 minus 4 is not 0. But the second one works because this will be -1, -4, -1, +6. So all this gives you -6 plus 6 is 0. So if that is the case, then it means that r, so take this to the left-hand side, r plus 1 is a factor of r cubed minus 4r squared plus r plus 6. And if r plus 1 is a factor, then it means that it can divide that polynomial without a remainder. So you can either use synthetic division or we can use long division. So if we are to use long division, yes? Ask. So we say that when r equals to -1, if you put in this equation, it gives you left-hand side to be 0. So 0 equals to 0 is a true statement. Okay? Now, so when r equals to -1, so when we say r equals to k, means r, if r equals to k satisfies a given polynomial in terms of r, then that means that r minus k is a factor. So just like if I have x squared plus 5x plus 6 equals to 0. So x equals to -2. Let's see whether they satisfy the equation. So we have -2 squared plus 5, -2 plus 6. Does that give us 0? Yeah, this is 0. So if that is the case, then it means x equals to -2 is a root of x squared plus 5x plus 6 equals to 0, means So then take this to the left-hand side. X plus 2 is a factor of x squared plus 5x plus 6. And you can confirm that. Possibly just x plus 2 times x plus 3. You get that quadratic. Huh? Okay. Yeah. So when you want to, so once you confirm that a given value of x is a solution to a given equation involving x, now when you take that value to the left-hand side of that relationship of x equals to that number, you get now a linear expression that is divisible or that is a factor of the polynomial expression on the left-hand side. So that's what we are doing here. So that's where the r plus 1 is coming from. Can you allow me now to proceed? Can I proceed? Yeah. So r plus 1 is a factor of this cubic polynomial. So what you do, long division, you will say r plus 1 into r cubed minus 4r squared plus r plus 6. Yeah, the normal way we divide numbers. So that is structure of long division. To carry out division of polynomials, the degree of the polynomial is what matters in the computation. So for instance, we have a polynomial of degree 1, r plus 1, and a polynomial of degree 3, r cubed minus 4r squared plus r plus 6. Ask yourself, what should I multiply by r to get r power 3? R power 2. So r squared by this will give me r power 3. R by 1 is give me r squared by 1 will be r squared. Then you subtract in the usual way. And you subtract like terms. R cubed minus r cubed is 0. Minus 4r squared minus r squared will be minus 5r squared. Bring this plus r. Bring this plus 6. Next, what should we multiply by r to get minus 5r squared? Minus 5r. So minus 5r by this will be minus 5r squared. And then minus 5r. So 6r plus 6. Well, we'll have minus is plus. So 6r plus 6. So what should I multiply by r to get 6r? 6. So 6r plus 6. And when you subtract, you get 0. Yeah, so that means that the equation r cubed minus 4r squared plus r plus 6 is nothing but r times r squared minus 5r plus 6. Okay. I hope now you can finish from that point. Also, it's not very hard to get the solution to the quadratic. So you'll be equating this to 0. Okay. Which one? Okay, so you for this problem you can finish from this point, okay? Because will be r plus 1 or r squared minus 5r plus 6 equals to 0. So you'll get two roots from here. You get your R1 to be -1, R2, and R3 will be obtained from this quadratic. And you can give the structure of the solution. Okay. Yes. Yeah. Is it? Is it a must? For this course, it's not necessary. You can as well, if you have a powerful calculator, you can do them. Yeah. If you have a serious calculator, it can give you the answers to a cubic equation. There's no problem. So this was done in calculus. You are lucky that you survived first year. So this should have come out clearly in calculus when you're doing limits, when you are having limits of rational polynomials. Yeah. You can as well also read on synthetic division, how it works. Sometimes it can also help you to do the same problem. So what I gave was a cubed y dx cubed minus 3 dy dx plus 2y equals to 0. I trust you can do all the process that leads to characteristic equation from our previous practice. Yeah. So what would be the characteristic equation? R cubed minus then plus 2. Correct. So ask yourself, in this case, we can't really do direct factorization, but the constant number is what is going to help us to see the factors of this given cubic equation. So the constant is 2. What are factors of 2? 1 and 2. And then you make them plus minus. So use them to test which value of R satisfies the equation. So when R is, say, -1, so we'll have -1 cubed minus 3 -1 plus 2. Is that 0? So +1. So that it's not a good choice. So this is not 0. So it's a bad choice. If R equals to +1, so we'll have 1 cubed minus 3 by 1 plus 2. Does that give us 0? So if it's 0, then we are lucky. So this will help us to get the factors of this cubic equation. So if R equals to 1 is a root of R cubed minus 3R plus 2 equals to 0, then dash is a factor of R cubed minus 3R plus 2. What should I write in that space? R minus 1, correct. So we are simply taking now this number to the other side. So we'll have R minus 1. So we use long division. So R minus 1, let's see how many times it divides R cubed minus 3R plus 2. So what should I multiply by R to get R cubed? R squared. So I'll have R cubed minus 3 minus just R squared. And you see, in the numerator, we don't have a term with r power 2, but who said that it can't be there? So 0 r2 minus r, 0 r squared minus r squared is 0 r squared minus r squared will give us positive r squared, and then bring this minus 3r, bring this positive 2. And then what should I multiply by r to get r squared? R. So plus r. So r squared minus r. Then subtract. Yeah, this is the last example. I know you are tired. Minus 3r minus r. So then minus 2r. Then bring the 2. Then what should I multiply by r to get minus 2r? Minus 2. So minus 2. So minus 2r. Minus 2 by minus 1. Plus 2. So when you subtract, we are sure you'll have 0, okay? So that means that the cubic equation is nothing but r minus 1, r squared plus r minus 2 equals to 0. So which means r minus 1 equals to 0, or r squared minus plus r minus 2 equals to 0. So here I'll have r equals to 1. These are the equations. So this is r1. Help me get r2 and r3. Solve this quadratic. Also 1, correct? Negative 2, fine. So what would be the y1 solution? If that is the case. Almost. Y1 will be e power x. 1 times x is just x. And then what will be y2? No, that is, so remember r1 and r2 are, yeah, how to multiply it by x. We need 2 independent solutions. So we have to multiply that by x. And what is y3? E power negative 2. Yeah. So y of x is c1y1 plus c2y2 plus c3y3, which will give us y is c1 e power x plus c2 x e power x plus c3 e power minus 2x. And you get your 2 marks. So that's how we're supposed to solve that. So I usually know the strength of my class. So with all those examples we have done, I trust you can finish the assignment given. If you have not done, if you are not done, or if you did and you think there's something you need correct, I can give up to Friday. I'll create another link for those who may have already submitted and think they want to do some corrections. I'll open it up to Friday. Okay, please, about the cat. I was both happy and unhappy by the performance. Happy because a majority of the people understand what they are doing, and happy because some people are not right in mathematics. So when you find someone says that dx of e raised power x is given by x e raised power x minus 1. That one, even St. Peter's will not be happy with you when you are said you can be taken to hell. Dx of e raised power x, you write x e raised power x minus 1. And to make worse, to make matters worse, this is the working for this particular X student. I will not call you by your name. But when it comes to the answers, the person has 98%. Can you trust this process? If you are me, the person on the workings, they say ddx of e power x is x e power x minus 1. But now when I go to the spaces where the link where the questions were to fill in the answers, the guy has 98%. Is this a genuine work? This probably is not true. And then I was happy by people. Some people, someone has filling has 40% as what is in the spaces that you are to fill in. But when I go to workings, I see things which make sense. So someone has 40% on the answer that are filled in the workings, most of the steps are correct. So this is really, this is what actually I got out of this. So this person will send the solutions, but was not given the workings. So they decided to fill in the solutions and then get their 98%. Too bad for you. The final mark is what you fill in and your workings should tally. So the famous 159, the famous 159 list, all these people scored above 70% in the fill-in answers. In fact, there are 2 people who have 100%. But after going through all these scripts, all these 159 scripts, the maximum marks I could get for this group of 159 was actually 63% when I marked the workings on how the answers obtained. So he told me that there's something that probably might have happened. So I'm going to open the link to the solutions. You see your marks, but at the end of the day, I'm still finalizing to mark the workings. What you see on that link for the fill-in spaces should not cheat you that you have 100%. The 100% will be confirmed once the workings and the answers agree. So if you have to copy, you have to be very smart. So also have the correct solutions. So I give you powers to go and read more on higher order differential equations. And please, if I give some work for you to go and do it. Because probably that's why I'm going to get some problems for the exam. There's 70% chance that the exam will be physical. So for those who are doing e d dx of e power x as x e raised power x minus 1, and you get 98%, please ensure that you recheck your work so that when you are brought in, you can confirm the 98%. So there's no problem in discussing. You may discuss, but ensure that you gain out of it. Don't allow yourself to be send the answers and then you just scan. Say the same in those answers. So with those many remarks, we used to stop there. Yes. Obviously, I cannot trust this 159 scripts. We will have it. Everything matters. You cannot be doing things which do not matter.